Hey you guys, I'm going to read aloud the review book assignment for days 3 and 4, pages 82 through 84. And while I read, I'm going to be underlining important information and making some text annotations. Energy and Earth processes. Topic overview. Energy, like mass, time, or distance, is one of the basic attributes of the universe. Energy is the ability to do work. Everything you do, in fact, everything that is done in the universe involves the use or transfer of energy. Earth can be described as a huge machine driven by two major heat engines, one external and one internal. Earth's external engine, the one that drives most Earth surface processes, is powered mainly by energy from the sun. Heat from the interior of Earth and the resulting mechanical energy powers Earth's internal heat engine. Electromagnetic energy. Visible light is the type of electromagnetic energy you are probably most familiar with. Visible light waves are the parts of the electromagnetic energy that is radiated by the sun and observed with the human eye. Electromagnetic energy is a type of energy that is radiated or given off in the form of transverse waves from all matter, not at absolute zero. Absolute zero, that is 0 Kelvin or negative 273 degrees Celsius, is theoretically the lowest possible temperature and the one at which particles of matter have no motion. Transverse waves vibrate at right angles to the direction in which they are moving. Characteristics and types of electromagnetic energy. Different types of electromagnetic energy are distinguished by their different wavelengths. The wavelength is the distance from one crest of a wave to the next crest. A wavelength may also be described as the distance between any two corresponding points on successive cycles, as shown in Figure 5.1. Figure 5.2 shows the various types of electromagnetic energy in order of increasing wavelength. Any model that shows the type of electromagnetic energy is known as an electromagnetic spectrum. Visible light is the only part of the electromagnetic spectrum that can be seen by the human eye. Infrared energy is often felt due to its heating effects. So I'm going to make some little symbols here. I'm going to make an eyeball, and this is going to be visible light. And then I'll make a little hand. 1, 2, 3, 4, 5. Okay, that's a hand. And that's going to show infrared energy because we feel infrared energy. Instruments must be used to observe most forms of electromagnetic energy, including ultraviolet energy, which tans or burns the skin. Electromagnetic energy can be separated into two groups by comparing its wavelength to those of visible light. It is called long-wave electromagnetic energy. Electromagnetic energy with a wavelength shorter than visible light is called a shortwave. Sometimes scientists include visible light as a type of short-wave radiation. Interactions between electromagnetic energy and an environment. When electromagnetic energy comes in contact with a material, the waves interact with the material. The waves may be refracted or bent in their passage through materials of varying density so that the direction of the waves is changed. So I'm going to put here refracted means bent. Reflected or bounced off of the material scattered or refracted and or reflected in various directions, transmitted or passed through the material, absorbed or taken into the material. Surface properties and absorption. Characteristics of a surface determine the amount of electromagnetic energy that can be absorbed. For example, the darker the color of the surface of a material, the more visible light it will absorb. This is the reason that a dark-colored asphalt road feels hotter to the bare foot on a sunny day than a light-colored concrete road. Color is the way the human eye distinguishes the various wavelengths of visible light. The texture, roughness, or smoothness of a surface also affects the amount of electromagnetic energy absorbed. The rougher a surface is, the more energy it will absorb and the less it will reflect. For example, mirrors are shiny because they are smooth and reflect most of the incoming visible light. The more effective a material is at absorbing electromagnetic energy, the better it also is at radiating or giving off electromagnetic energy. Thus, a dark-colored object will heat up quickly in sunlight, but it will also cool off quickly after sunset because it rapidly radiates electromagnetic energy. The result is that of a concrete road will be warmer a few hours after sunset on a sunny day than will a road made of asphalt. Review questions. Number 1. Which is the major source of energy for most of the Earth's processes? 1. Radioactive decay within Earth's interior. 2. Convection currents in Earth's mantle. 3. Radiation received from the sun. Or 4. Earthquakes along fault zones. Number 2. All objects warmer than 0 Kelvin, absolute zero, must be 1. Radiating electromagnetic energy. 2. Condensing to form a gas. 3. Warmer than 0 degrees Celsius. Or 4. Expanding in size. Number 3. The various types of electromagnetic energy are distinguished from one another by their 1. Temperature. 2. Wavelengths. 3. Height of waves, or 4. Speed of travel in space. Number 4. Which type of electromagnetic energy has the shortest wavelength? 1. Ultraviolet. 2. Visible light. 3. Gamma rays, or 4. Radio waves. Number 5. In the visible spectrum, which color has the longest wavelength? 1. Red. 2. Green. 3. Orange. 4. Violet. Number 6. Which statement about electromagnetic energy is correct? 1. Violet light has a longer wavelength than red light. 2. X-rays have a longer wavelength than infrared waves. 3. Radio waves have a shorter wavelength than ultraviolet rays. Or 4. Gamma rays have a shorter wavelength than visible light. Number 7. As electromagnetic energy from a heat source interacts with its environment, it is being 1. Reflected only. 2. Refracted only. 3. Absorbed only, or 4. Reflected, refracted, and absorbed. Number 8. Which electromagnetic energy travels from air into water? The waves are bent due to the density differences between the air and water. What is this bending called? Number 9. Which would absorb the most solar radiation if you assume that each covers an equal geographic area? 1. A freshwater lake. 2. A snowfield. 3. A sandy beach. Or 4. A forest.